All right, lesson 9.8, sorry, this is lesson 9.8, part 2. We just talked about how we might be able to analyze a function and determine if it was linear, and if we have an arithmetic sequence in the first differences of the range, we're going to end up with a linear function. But what if the data isn't linear? We can continue to analyze our data. And here's a second example. So right down here we have a second example. First step always is to figure out, well, do I have a consistent interval in my domain? And sure enough, I do. I'm just adding 1 each time. That makes life really easy. So now I'm going to start looking at my range values. Remember, if I can find the differences, meaning if I do 2 minus 4 to analyze these two items in my range, and I get -2, okay, well then I'm wondering, well, what's 1 minus 2? Am I going to get the same difference here? 1 minus 2 equals -1. No, this is not arithmetic. What we're not coming up with is a consistent difference between successive terms in the in the range. So we've analyzed our first differences and no, it's not arithmetic. So the next thing we might want to ask ourselves is, could this possibly be geometric? Meaning, instead of having a common difference, do the range items have a common ratio? If they have a common ratio, that's going to help us figure out what kind of model that is. Well, what do I do mathematically to get from 4 to 2? Well, I could subtract 2. I could think about that. That would be a common difference of -2. And if that's true, if I have a common difference of -2, well then this had better be 0, and it's not. So that might not be the way to go, but if I don't subtract 2, could I divide by 2? In other words, could I multiply by 1/2? All right, let's see if that works. If I'm multiplying by 1/2, and we have figured it out. In this particular set of data, what we have is a geometric sequence in the range. And what does that tell us? That tells us that the data is exponential. And then let's just remember what the exponential function is. Y equals a times b to the x. So if we're asked to write the equation for this function, well, we need to know two things. We need to know what a is, and we need to know what b is. And we can figure that out. We can go back into the data, and we have some x's and y's. So I can start by just defining what a is. So I can use this order pair, and I can say, well, when y is 1, I have a times b to the 0. Well, that just means that a equals 1. That's super helpful. So now I can use another ordered pair. I'll just use this one. So that means that when y is 2, and then a is 1 times b to the -1. 2 equals b to the -1. 2 equals 1 over b. b to the -1 is 1 over b. I could multiply both sides by b, so that means 2b equals 1, in which case b equals 1/2. Remember that the common ratio ends up being that base. So now we have figured out what we need to know. We know that a equals 1 and that b equals 1/2. So our equation equals y equals 1/2 to the x.